Okay, so we're back for example 9. So this time we have a binomial, 8a to the 4th minus 10, times a trinomial, so 3a to the 6th plus 2a to the 3rd minus 4a. So again, we just think about that general idea that each term in the first polynomial is going to get multiplied by each term in the second polynomial. So 8a to the 4 gets multiplied by 3 things, and then negative 10 gets multiplied by 3 things. Again, we'll end up with 6 altogether, and then we'll combine them if we can. So 8a to the 4th times 3a to the 6th is 24a to the 10th. 8a to the 4th times 2a to the 3rd is 16a to the 7th, right? Remember, I'm multiplying the coefficients and I'm adding the exponents. I'm watching my signs, so 8a to the 4th times negative 4a, 8 times negative 4 is negative 32, and then a to the 5th. Then I'm going to multiply negative 10 by all of those, so I get negative 30 a to the 6th, negative 20a to the 3rd, plus 40a. So because there is no a here, I'm not adding anything to that exponent. So each of those just has the same exponent they started out with. Just the coefficients are multiplied by negative 10. Okay, so now when I look at this, I actually don't have anything that I can combine. They're all different exponents. The only thing I would want to do is I would want to rewrite it in standard form. So I have a to the 10th, then a to the 7th, then I'm going to swap these two, right? So I am going down in order of exponents, so minus 30a to the 6th, minus 32a to the 5th, minus 20a to the 3rd, plus 40a. So that's going to be my final answer. Okay, so that's our multiplying. So we've gone through adding, subtracting, and multiplying. What we're going to do next is dividing. And there are two different types of division we're going to look at, okay? So the first one there says dividing a polynomial by a monomial. So in this example, let's just take a look at why that's what we're calling this. So we're going to have 3x to the 5th plus 6x to the 3rd minus 18x squared plus 12x. And I'm dividing by 3x. Okay, so I'm taking this polynomial with 4 terms and I'm dividing it by just one term, by a monomial. So this is one of our situations, okay? Basically the two situations we can have with division is that we have a polynomial divided by one term, a monomial, or a polynomial divided by more than one term. And so we attack those two different ways. So first we're going to look at ones where there's just one term here. And if you look at the steps at the top, it says write each term of the dividend. This is the dividend, and this is the divisor. I have that written up at the top. Write each term of the dividend as a fraction with a divisor in the denominator. So if I'm dividing, another way to write a dividing sign is as a fraction bar, right? So I could really say, okay, this is the same as this. Now, in order to simplify this, what we're going to do is we're going to write these as separate fractions. We've done this before when we were solving for y equals mx plus b form. We divide by whatever's in front of the y. On the other side, we write it under each term separately. It's the same idea. So I'm going to have 3x to the 5th over 3x plus 6x to the 3rd over 3x minus 18x squared over 3x plus 12x over 3x. Okay, so just take a minute to look from what we have here to what we have here to make sure that you see where each of those parts came from. Okay, so now we're going to handle each of these fractions separately. And I'm going to tell you that if you look at this one, for example, that's something I could have given you last chapter. Each one individually is something that you could have done last chapter. We're just using our exponent rules. So again, nothing really new here, okay? So 3 divided by 3 is going to be 1. X to the 4th divided by x, remember that we're subtracting exponents. So we get x to the 4th. Here, 6 divided by 3 is 2. X to the 3rd divided by x to the first is x squared. Here, 18 divided by 3 is 6. X squared divided by x is just going to be x, right? 2 minus 1 is going to be 1. And over here, 12 divided by 3 is 4. X divided by x cancels out. Or you can think x to the first over x to the first means x to the 0, which is just going to be 1. So again, this is going to be my answer there. I can't combine those like terms. I'm just going to leave them as 4 separate terms. Okay, so let's look at the last example here of this type. All right, so example 11. I'm going to start right out writing it as my fractions, okay? Because we can see it's this 4 terms divided by 1 term. So I'm going to start right out rewriting it with that monomial in my denominator. So the first term of the polynomial over the divisor. The second term of my dividend polynomial over my divisor. So hopefully you see where I'm getting each of these terms here. Okay, so we're going to have a bunch of things come up in this one. The first thing is that in the last one, all of our coefficients divided nicely. Okay, they divided out to an integer. That doesn't always happen, and that's okay. So if your coefficients do not divide like this, you can turn it into a decimal if it comes out evenly. If it were going to be a repeating decimal, I wouldn't, but really I would suggest just leaving it as a fraction. If you can reduce the fraction, do that, but if you can't, just leave it. So 15 over 2 is just going to be part of my answer. Okay, and then x to the 4th divided by x squared is going to be x squared. You can either write it like this, or you can write the 15 halves just outside of the x squared. They both mean the same thing. Let's go on to the next one. Negative 10 divided by 2 is going to be negative 5. X squared divided by x squared cancels out. So I have no x's there. Oops, this is x to the 3rd. Sorry about that. Okay, so now there is an x there. That's the kind of thing that usually in class someone yells at me about. So I need you guys here to correct my mistakes tonight. Okay, let's go to the next one. Now there's a 1 here. So again, this isn't going to divide into an integer, but I can just leave it as 1/2. Now this time, I really do have x squared over x squared. That's not going to leave me any x's. So it's just 1/2 there. Now let's go to the last one. 6 divided by 2 is 3. Look at what we have for our exponents here. This is the part that gets a little crazy, okay? I have x right here and x squared here. Well, think about my exponent rules. So if I'm going to divide these, x to the 1st over x to the 2nd, 1 minus 2 is negative 1. Okay? We can either write it like that, and this could be our answer, or we can use what we know about negative exponents, and you could write it as 3 over x. Either of those is perfectly fine. Okay, so these two examples were showing a polynomial divided by a monomial divided by just one term. Now, the next thing we're going to do is a polynomial divided by a polynomial. And I would never normally say this in a regular semester, but I'm going to say what's most important is to understand up to here. Okay. The next part, there's one question on it in the homework, and there are no questions on it in the test for this chapter. It's important to know, but you will also go over it again in Math 120, if you move on to Math 120. So, because of the way this semester is, I don't want you to, it's a hard topic, and I don't want you to get super, super stressed over it. So I'd like you to watch the videos on it. I'm going to start a little bit here, and then probably have to do another video. But if you have to prioritize your time, go up through here, okay? And the way we do the next ones is with polynomial long division. Put that on the back burner if you need to. Okay, so when we're dividing by something that has more than one term, then we have to use long division. So first we're going to just review long division with just plain old numbers, with integers. So if I have 2,892, and I'm dividing it by 3. First of all, again, this is the dividend, this is the divisor. So my dividend goes inside the dividing sign, and my divisor is what goes outside. And if we think about this really step by step, because then we can kind of translate it to what we're doing with the polynomials. 3 can't go into 2, but 3 can go into 28. It can go in 9 times. So then we usually go through this in class and someone says, okay, well, you subtract 27. Well, where does the 27 come from? That's because the next thing I really do is multiply these two. So I multiply those, I subtract, and then I bring down the next number. And from this point on, it's all just a repeat of what we already did. So I see how many times 3 goes into 19, which is 6. 6 times 3 is 18. I subtract, I bring down. 3 goes into 12 4 times. 4 times 3 is 12. If I subtract and get 0 as my remainder, then that means that there's nothing left over. So what this means is, let's say I had 2,892 marbles spread out on the floor, and I put them into 3 groups. I would have 964 in each group. Or, another way to think about that is if I group them into groups of 3, I would have 964 groups of 3. In this case, every single marble would be in a group. There wouldn't be any left over. Okay, so I'm close enough to my time limit that I'm going to start a new video for example 12, but keep this in mind. We're going to go through all of these steps with polynomials. All right, so I'll be right back with example 12.